So first is what are the hormones from the hypothalamus? So there's the hypothalamo pituitary x-axis. So it could be adrenal, it could be gonadal. So that will be HPA is adrenal, HPG is gonadal, and so on. And so what comes from the hypothalamus in response to different stimuli would be releasing hormones, and they all, they end in releasing hormones, and some go to the anterior. These are the ones that go to the anterior pituitary that have the releasing hormones. The ones that so let's actually go there. So corticotropin releasing hormone, thyrotropin. So if you notice the tropin, when you say tropin infers growth, something that makes something grow or become more functional. So corticotropin releasing hormone, it will be released from the hypothalamus and it will be released to the anterior pituitary. And each of those hormones will interact with specific cells in the anterior pituitary, which will make the next set of hormones. So, for example, you have um, growth hormone being released, and then you have follicle stimulating hormone, luteinizing hormone, adrenocorticotropic hormone, and those secondary hormones that are released from the anterior pituitary then go on to be released into this general circulation, and they would now stimulate specific organs. And so, for example, the growth hormone goes to the liver cells, the hepatocytes, and it stimulates, that's actually the hepatocytes, it stimulates the cells of the hepatocytes to make um, insulin like growth factor 1, which will now go onto the muscles and the bones and so on. And then you have the follicle stimulating hormone, which goes to the gonads and enhances the maturation of the um, of the gonads, both males and females. It would cause egg maturation and estrogen production in females and sperm production in males, and so on and so forth. Prolactin will go on to stimulate breast growth. Now, then the posterior pituitary, on the other hand, the the cells that that originate from the hypothalamus and end in the posterior pituitary release some hormones directly into the general circulation. And those hormones, there's two of them, antidiuretic hormone and oxytocin. Oxytocin will increase milk let down, and it will also cause uterine contraction. So it would stimulate the breast, and it will also stimulate the uterus. What else? What does antidiuretic hormone mean? What does it do? As the name sounds, antidiuretic. So diuretic is when you pee more. If a hormone is anti that, it means you don't pee. So the other name for the hormone is vasopressin. So the saying is um, when when it's low, that is when vasopressin is low, you are really pressed to go. Okay. So again, rhyming is a thing for my kids. I have really young elementary kids, and so when vasopressin is low, you are really pressed to go because you're going to be making a lot of urine. Okay, so that's that. And then next is the thymus gland. So the thymus gland is a really tiny gland. That actually in adults it shrinks progressively throughout life. It's more prominent in children, but what it helps to do is it makes this hormone thymosin and thymulin, and these hormones help with the maturation of T cells. As a matter of fact, the word T cells takes the T from thymus. It's the place in your the thymus gland is one of the original places when you were a child where your immune cells, your T cells that will end up going to attack, infections. That's where they are basically schooled. That's where they are prepared to be able to attack foreign cells. And so, if for whatever reason you lose your thymus, you will lose your immunity, your adaptive immunity. Next is the thyroid gland. So it's on either side of the larynx. And it's quite a large organ, and it could really enlarge. So what is shown here in the center here is a histology section of the thymus, and this structure here is called a thyroid follicle, and around the follicle, the cells that line the follicle are called the follicular cells, and those cells are the ones that make um, thyroid hormone as well as thyroglobulin. But whatever it is, they're the source of thyroid hormone. And thyroid hormone, when it's released, goes to virtually every cell. It's calorigenic, that is, it causes glycogenolysis, meaning you break down glycogen to make glucose. Again, you're calorigenic. You break down fats to use that for energy. And because part of that also, it will go to the mitochondria in these cells and make them generate more ATP, and as a result, it generates heat. That's why they're calorigenic, and so they would cause your heart to go faster and beat even stronger. And so the other cells here are your parafollicular cells. They're really much smaller cells, and they release calcitonin. When I say smaller, I mean in population. They release calcitonin, and calcitonin is actually it tones down the calcium in your blood. It reduces the amount of calcium in the blood by enhancing the ability of the kidneys to excrete calcium, among other things. So the next organ here is the adrenal cortex, is the uh, adrenal gland, and there are four layers here from the outside to the inside. You have the glomerulosa, so that's M in the middle. The gloma stands for like a ball of yarn. If you look at this is based on how it looks to the eye. And next is the fasciculata, and the third one is the reticularis. And the medulla is on the inside. It's not part of the cortex. So cortex is actually the same. It's from the Latin word that means like the rind. If you think of the rind of a fruit, so this is just the rind. The medulla is the middle, is not part of that rind. It's like the pulp of your fruit is different from the skin of your fruits, basically. So the medulla is what makes epinephrine. But the glomerulosa makes the mineralocorticoid. So one mineralocorticoid is aldosterone. So minerals. Aldosterone is what governs how much sodium and potassium is lost from the kidneys. It acts on the collecting duct to help insert sodium, potassium transporters. And so again, it's pretty important. If you block aldosterone, guess what? You're going to pee more. Um, okay, so aldosterone, in a sense, works has an anti-diuretic effect. It's not antidiuretic hormone, but it does have an antidiuretic effect. When you have a lot of aldosterone in the system, you will have a lot of transporters for sodium to take sodium out of the urine. And when sodium goes out, water follows, and so you will make less urine. Okay, so that's why we call them mineralocorticoids, like your minerals. Sodium is a mineral. And then you have your fasciculata. That's the one that makes your glucocorticoids, cortisol, that is released in stress. And part of the effect in stress is it actually helps to recruit glucose in order to fight the stress, fight whatever the stressor is. Um, so that's cortisol. And then you have the reticularis. Reticularis stands for like network, like a net. And so I use the T in network or reticularis to just kind of help you remember that this is where you make your androgens. Androgens for both males and females. It is ultimately converted to estrogen in females, but um, the this is where it's made. So you make epiandrosterone. That's one of the precursor androgens that would end up becoming testosterone or other things. And then from the medulla you make cortisol. So where does aldosterone work? Of course, works on the kidneys. Where does cortisol work? It works a lot on a lot of your immune cells. It works a lot on your muscle cells. It works on virtually all cells. It helps again to recruit glucose. And then you have the adrenal cortex, the testosterone. You know what that does. It goes to the reproductive organs and helps to the maturation and all of that in the male system. And then when you talk about epinephrine, epinephrine is both a hormone and a neurotransmitter. Okay, I'll say that again. It is both a hormone and a neurotransmitter. But whatever the source, it will stimulate your peripheral organs, your autonomic organs, that is your involuntary organs, like your heart. It would also make your bronchioles to dilate, for example. And so it acts on many smooth muscles, like the smooth muscles of your blood vessels in your skin. It will contract them. So if you notice, when you're scared, the your blood vessels will become much more tiny, and you lose color on your face, especially if you're light skinned. Next is the pancreas. So the pancreas, of course, there's the endocrine and exocrine pancreas. So now we're talking about the endocrine, meaning it releases the content into the blood, not into the gut. So that's the exocrine goes into the gut, the endocrine goes into the blood. And the functional unit here, so this is the histology, and that's what you call an islet right here within that structure of the pancreas. And the islet of Langerhans, and let me just, so this cartoon here has several cell types. You have alpha cells that make glucagon, beta cells that make insulin, delta cells that make somatostatin. But for now, just know insulin and glucagon. And insulin, of course, works on the liver, the muscles, the fat cells, and it is a what you call an anabolic hormone, meaning it helps to store nutrients and helps to build bigger things. So you will take glucose and help to build glycogen. That's one of the ways insulin takes away glucose from the blood after a meal, is because it helps the muscles take it in and also now store it as glycogen. I like that. That rhymes. It helps the muscle take it in and then store it as glycogen. So that reduces your blood glucose. It also helps the liver do exactly the same thing. Fat cells, it helps the fat cells again to store fat within them. So again, it's that's why insulin is really an important hormone. And then you have glucagon. Glucagon does the opposite. It will help to break down glycogen from the glycogen stores in the liver. It will help you also to break down fat, and so you can use fat for energy. Again, it's kind of yin and yang, so both of them. And then you have your gonadal gon- sex hormones. Okay, you know what I mean. So sex hormones. So you have testosterone, estrogen, and progesterone. For now, it's sufficient to know that they will cause maturation and function of the male and female reproductive systems. And this is a feedback mechanism. So again, you've seen this before. TRH is made from the hypothalamus. It goes to the anterior pituitary, which makes the thyroid stimulating hormone, which once it gets into the blood, goes to the thyroid gland. And in the thyroid gland, what does it do? It will stimulate the production of thyroid hormone. Thyroid hormone, once it gets into the blood, goes on to um, cause a lot of effects. So it's calorigenic. It will cause your muscle cells as well to even um, to generate more heat and make use more ATP. Your heart again pumps more, pumps faster. So one of the things you have with people that have raised thyroid hormone is their hearts are typically enlarged over time. All right, so just to quiz ourselves here, and I'd like to hear your answers. So, what do you think number one, two, three, four, and one to seven? What are they? So fill that out. Take the hints from what is on the chart and share that with me. Next is and so just for an example, so the first one here, it ends in controls metabolic rate, so that must be thyroid hormone, and it shows here this figure from your textbook essentially what we've described before. So thyrotropin releasing hormone, thyroid stimulating hormone released here goes to the thyroid gland, releases thyroid hormone, goes into the blood, and that goes to your liver. What does it do to the liver? It causes glycogenolysis. You break down glycogen to glucose and use that for energy. Again, that generates heat. It goes down to fat tissue. It causes lipolysis. You break down fat to again make energy and calories. It goes to your lungs and it increases your breathing rate and your heart rate and so on. Okay, so that's that, and it also shows the negative feedback. That's not shown on this figure, or it's shown there, but I didn't put the negative sign. So, thyroid hormone that is released will go back and will inhibit the here the anterior pituitary from making more thyroid stimulating hormone. It will go here to the hypothalamus and decrease the release of thyrotropin releasing hormone. So that's that. And there's this one, which again I want you, which system do you think is involved in this story? Story of Andre the Giant. So which of these pathways, A, B, C, or D? I would like you to share your thoughts with me or with your peers.